Lesson 14.2, Task 6. Convert between forms of geometric sequences. The frequency of a piano A note halves from one A note to the next lower note. The explicit rule for this sequence is G of n equals 3520 times 1/2 raised to the 7 minus n power for all n between 0 and 7, where n is an integer. Convert this explicit rule to a recursive rule, then check the recursive rule by using it to generate the sequence. Alright, so first determine the first term and the common ratio. So G sub 0 equals 3520, and the common ratio R is 1/2. So that's given right here. Okay? Alright, to write a recursive rule, we're going to say G of 0 equals 3520, so G of n equals 1/2 times G, 1/2 G of n minus 1. And that's for all n between 1 and 7, where n is an integer. Okay, so this is your explicit rule. This is your recursive rule using the information given. All right, so it says, what is the relationship between the common ratio of this explicit rule and that of the explicit rule from the previous task? So the two common ratios, if you remember, the one from the previous task was a 2, and this one is 1/2. So they are reciprocals. And in the previous task, the explicit rule modeled the frequency from one A note to the next higher A note. In this task, the explicit rule models the frequency from one A note to the next lower A note. If you go back up here, it says A note to the next lower A note. So a little bit of a difference. That's why the formulas are a little different. And then it says use the recursive rule to generate the sequence. Multiply each term by 1/2 to find the next term. All right, so we're given the first term, 3520. So we're going to start with 3520 and then multiply that by 1/2 and continue to do that, and that generates the sequence here. So let's see, we got 1, 2, 3, 4, 5, 6, 7. We did that 7 times because we went from 0 to 7 and 1 from 7. All right, so it says which statements about the domain of the explicit and recursive rules are true. So again, if you look, the explicit rule goes from 0 to 7, and the recursive rule goes from 1 to 7. So the domains are different. All right, so that means that the explicit and recursive rules have different domains. The explicit rule has the 0 included as well. All right, that is all for task 6. If you have any questions, let me know. Lesson 14.2, task 7. Apply geometric sequences. A biologist estimates the population of ants in a colony at the end of each year for 4 years. The populations are given in the photo. Year 1 is 1,000 ants. Year 2, 2,400 ants. Year 3, 5,760. And year 4, 13,824 ants. All right, so it says make a graph that shows the population at the end of each year. What will the ant population be at the end of 10 years if the population continues to grow at the same rate? All right, so to graph these points, you can see the 4 years are given, and you can see that it continues to grow more quickly each year. All right, so it says which best describes the points shown on the graph. The points appear to be a line. They do not appear to be a line. If they were a line, they would be more this direction here. They appear to be exponential. Okay, it does look exponential because it grows at a faster rate. All right, it says the sequence 1,000, 2,400, 5,760, and 13,824 models the annual ant population. Determine whether the sequence is geometric. All right, so remember you can take this number and divide by this number divide by this number, and this number divide by this number. So take a number and divide it by the previous term, and that's going to give you your R, your ratio, your common ratio. All right, and if each of those equals the same common ratio, that means it is a geometric sequence. So in this case, this is a geometric sequence. All right, so it says, how do you know that the annual ant population forms a geometric sequence? Well, because they did the division here, and each time they got 2.4, so that 2.4 is your R when your common ratio is the same, or when your ratio is the same, it's a common ratio, and that makes a geometric sequence. All right, so it says write an explicit rule. Use the first term, 1,000, okay? So if you go back up here, you can look and you can see that in year 1, there was 1,000 ants. So that's your first term. I'm trying to keep track of where I am. All right, so we're going to use the first term and the common ratio to write the explicit rule. All right, so we'd have f of n equals your first term, which is 1,000, times your common ratio to the n minus 1 power. In this case, the common ratio was 2.4. So then the question was, find the population at the end of 10 years. So we want to find f of 10. So you simply plug in 10 for n. So n, or 10 minus 1 is 9. 2.4 to the 9th power times 1,000 equals 2,641,807. You can't have 0.54 ants, but it says the ant population after 10 years will be about 2,642,000 ants. Shoo, that's a lot of ants. All right, if you have any questions, please let me know.